Hello everybody and welcome back to the 2017 MMC Manitoba Math Contest, and we're looking at question 6 in this video. How many times must one flip a fair coin, so 50% heads, 50% tails, to guarantee that the probability of getting one or more runs of 3 consecutive heads or tails is 50% or more? Justify your answer. Alright, well if I need 3 heads or 3 tails in a row, I obviously need to flip the coin at least 3 times. So, just to get us, just sort of to get us eased into the question, what is the probability when I flip the coin 3 times that I get 3 heads in a row or 3 tails in a row? Okay, and we can make a very quick probability tree for this. 3 is not that many. If the answer is going to be something like 20, we're going to want to generalize and understand patterns here, maybe make some more grandiose probability statements. But for figuring out just with 3 flips what the probability is, that's not going to be that hard. And it'll give us a base probability, and we could easily extend our tree to 4, to 5, to 6 if we need it, although 5 and 6 are kind of pushing it. But to better understand the probabilities there, if we need to generalize, if the answer is going to be something like 2017, I don't know. So, let's make our probability tree. So we start off, flip the coin, it's either going to be heads or tails. It's 50, each one of these branches can be labeled with a 1/2. 1 out of 2 times you'll get a head, 1 out of 2 times you'll get a tail. So from there, we can either get heads or tails, and branching off of there, heads, tails, and now, so this is my first flip, second flip, third flip, if you are having trouble reading probability trees. So now, to figure out the probability that we go down any one particular branch, i.e. that we go flip a head, and then we flip a tail, then we flip another tail, to figure out the probability that that happens after 3 flips, you just multiply the probabilities along each branch. But since each branch has a probability of 1 out of 2, each of these is 1 out of 2 cubed. Okay, each branch happens with a 1/8 likeliness. Okay, now we're not interested in just any old branches. We want those that have strings of 3 heads or strings of 3 tails. And so the 3 tails happens 1/8 of the time. 3 heads happens 1/8 of the time. And if we add these up, we get 1/4. So already, just flipping the coin 3 times, the minimum number that I need to get something like 3 heads, just flipping it 3 times, there's a 25% chance that I'm going to see 3 tails and 3 heads. Now, it's not the 50%, and it may be a while till we get the 50%, but we're sort of halfway there in a sense. So I wonder what happens if we extend this probability tree to the 4th flip. Okay? So there'll be 16 different branches, each with them 1/16 is the probability of getting that particular branch. But now there's more chances to have 3 heads in a row, because we could go tails, 3 heads, or 3 heads and then a tails, or heck, 3 heads and then a heads. Okay, so there's going to be more opportunities, and we're going to increase the probability that we get 3 heads in a row or 3 tails. Okay. Right now I'm suspecting that the answer might be something like 6. Just because 6 is the nice one where you can get 3 heads in a row and 3 tails right after it. Things like that. Anyway, let's erase these calculations. I don't want to redraw the whole thing, so we'll just continue on from here. So we can get heads or tails, heads or tails, heads or tails. I'm going to have to start going smaller. Actually, I need to make it bigger. So we'll go heads, then down here to tails, heads, tails, heads, tails, heads, tails, heads, tails, heads, tails. I probably should have drawn it in mind for doing a 5th column as well. but maybe this will be enough to generalize. I don't think so. It's only 2 possibilities. Heck, maybe 4 is the answer. Anyway, so each of these branches has a probability of 1/16. Now, which branches matter? Well, here's 3 heads, so we can either go 4 heads, that counts. 3 heads and a tails, that counts. Now, 2 heads, a tails, and a head, no, it's got 3 heads, but they're not in a row. Okay. Now, we can get tails and 3 heads, so that counts. How about heads and 3 tails? So that counts as well. 3 tails and a head, or 3 tails and yet another tail, so 4 tails. And now we've got 1/16, 1/16, 1/16, 1/16. We got 6/16. Now that's not 8/16, so we're not at 50%, but that's 3/8, so we've actually increased by an 1/8. Okay, so maybe the next one's going to be 50%, because then we'll have increased by yet another 1/8. Now, is there a quick way to calculate this that we can think of rather than just extending the table? Which I'm open to doing that, but well, let's think. How could I have 3 heads? So if it's 5, I mean, there are problems, there are overlaps when we get 6. But how could I have 3 heads at the very start? Well, I could have 3 heads and really anything else will do. So there's 4 branches that start heads, heads, heads and are fine. How about branches that have heads, heads, heads in the middle that aren't already counted? Well, that would force it to be tails, heads, heads, heads. And then there's sort of 2 possibilities that we can get there. And how about things that end in heads, heads, heads that don't already start with 2 H's or a TH? Well, that would have to start with an HT or a TT. Okay, so there's 2 ways to do that. So now there's 8 out of 32 ways to get 3 heads. And by similarity, or by symmetry, there's 8 out of 32 ways to get 3 tails in a row. There's no overlap. I'm not going to be able to have one of these strings be both 3 heads and 3 tails. There's only 5 of them. And you'll notice 8 over 32 plus 8 over 32 is 16 over 32, which is 1/2. So now we're at 50%. And it looks like, yeah, we did increase by an 1/8. Now, I don't know if we need to increase, we'll increase by an 1/8 for the next one, but are we not done the problem? 50% or more? Well, we got 50% right on with 5. So there we go, and I would justify my answer both with these charts that I've drawn and also my explanation as to how this counts as 4 branches, giving us heads, heads, heads. But 5 flips will do. Okay, not a whole lot of writing there, but explaining this part I think is key. And they wanted the minimum number, right? How many times must one flip? I would say part of the marks should also go to showing that 4 flips isn't enough. So I think that would count as well. So having this tree out there as well would give some marks, I would think. Okay. Not much to it. There was question 6. Up next will be question number 7. I will see you guys in the next video for that one.